Welcome to today's lesson. The topic of the day is on moles, and the subtopic is counting of atoms. Consider the following analogy. Assume that you work in a company and a person orders, you are in a company that sells marbles. Assume that a person orders 5,000 marbles. For you to be able to sell to them, you have two options. And the first option is to calculate 1 up to the time you get to 5,000 so that you give them their order. But then there is a simpler method. If you know that the mass of 5,000 marbles is 20 kgs, you just need to go to a weighing balance and pour out the marbles until the reading on the weigh balance is 20 kgs. Because you know that 20 kgs of marble gives a total of 5,000 marbles. You see? So we use the same knowledge to be able to get the number of atoms in a given element. Consider the example of carbon. In my sample here, I could come and maybe tell you that my sample that I have here has a mass, okay, maybe you don't know the mass, that has 6.0 times 10 to power 23 atoms. That is ideally what we call 1 mole, which ideally now is 602 exillion atoms. How am I able to get that the number of atoms in this particular sample is 6.02 times 10 to power 23? This knowledge is got from the mass number. When you study the carbon from the periodic table, we are told the mass number of carbon is 12. Okay? That is to tell us that the atomic number of carbon is 12. Also from the same periodic table, we know that the molar mass of carbon is 12.107. And now what is the molar mass? The molar mass ideally is the mass in grams of 1 mole of any substance. Remember that this number we are calling 6.02 times 10 to power 23 is what is referred to as 1 mole. So it is therefore correct to conclude that that carbon atom, which has a mass, the molar mass of 12.0 grams, in 12.0 grams of carbon, we have 6.02 times 10 to power 23 atoms. This number is the same number here which we call 602 exillion atoms, which ideally is 6.02 times 10 to power 23 atoms. What does that tell us? That tells that if you are told to get to the laboratory and get 602 exillion atoms of carbon, of course you cannot be able to count 1 up to the time you get 602. This is a very big number. It will take you billion of years to count from 1 to 602 exillion. So how do you get 602 exillion atoms from the laboratory? You just need to get 12 grams of carbon. Why? We know that 12 grams of carbon contain, these 12 grams of carbon contain this number of carbon atoms. Let's look at another example. We have sulfur, for example. Sulfur, in this sample of mine, I can maybe tell you that it contains 6.02 times 10 to power 23 atoms. Okay? It is possible for you to now wonder, how am I even able to calculate this gigantic number? We get to the periodic table. We know that the molar mass of sulfur is 32. So if the molar mass of sulfur is 32.07, this means that 1 mole of sulfur contains this particular number of atoms. Okay? So if I was to get you maybe to the laboratory and tell you, get me 6 or 2 exillion atoms of sulfur, you don't need to calculate 1, 2. Actually, you cannot be able to do that. Because if you decide to count 1 up to 6 or 2 exillion, it will take you more than billion years. So because now from the periodic table you know that the molar mass of sulfur is 32.07, you just get a weighing balance and measure 32.07 grams. Why? You know that 32.07 grams of sulfur contain 602 exillion atoms of sulfur. From that now we can get the conclusion that sulfur, 1 mole of sulfur contains 602 exillion atoms of sulfur. And from the foregoing now, because we know that the molar mass of sulfur is 32.07, therefore, cancel the zone please, this is 32.07, 32.07 grams. We know that now 32.07 grams of sulfur contains 6.02 times 10 to power 23 atoms, which ideally is 6 or 2 exillion atoms. Basically, that is how we are able to calculate the number of atoms from the mass number, or ideally the molar mass of any given atom. Thank you.